Alright, hi everybody. Today we're going to be working on area of a trapezoid. So trapezoid's not a shape that we're super familiar with. It also has kind of the longest area formula, but it is pretty simple. We should be able to take care of it. The area formula for a trapezoid is the area equals 1/2, so there's that 1/2 again. The base times the base plus the other base times the height. Now, while that sounds really confusing, I like to actually rewrite it like this. So we're going to do 1/2 times the height times base 1 plus base 2. Okay, and you're thinking, well, where did another base come from? Well, we're going to talk about that here in just a second. On your star chart, on your formula sheet, you may see it written like this. 1/2 base 1 plus base 2 h. That just means all of this is getting multiplied together and also multiplied times a half. I just wrote it in a different order that will make it a little bit easier for us. So real quick, let's talk about the parts of a trapezoid. A trapezoid has two parallel sides. This, oops, click the right thing here. This side right here and this side right here are parallel, meaning that they will never meet. Those two sides are actually also your bases. So you actually have two different bases. You have this base up here, and you have another base down here. Okay, why two different bases? Well, because where the area of a trapezoid formula comes from is it is based off of a rectangle. If I were to draw, and I don't know if I have enough room here, but if I were to draw another trapezoid of the same size connected here, whoops, let me fix that real quick. If I were to draw another trapezoid of roughly the same size connected to our other trapezoid here, you would see that I get a parallelogram, all right? A parallelogram. Parallelogram, remember, their area formula is area equals base times height. Well, if you check it out here, this base right here is actually down here. It's that same base that we're talking about here. So that's where this formula comes from. That's why we have to add the bases together, because it is coming from the area of a parallelogram. Here is your total base being multiplied to your height. Now, where that where that 1/2 comes from is because we only have one trapezoid, okay? There are two trapezoids right here. We only want to know the area of one, so that is why we have to cut the whole thing in half. So area of a parallelogram, remember, was area equals base times height. Base right here times, it would be our height, which is over here. Okay, that's where this formula comes from, and we're cutting it in half because we only want to know the area of one trapezoid. All right, so let me erase this extra trapezoid here so that it doesn't confuse you anymore. And let's talk about the height. Remember again that the height is a straight line connecting the tallest point of the shape to the lowest point of the shape. It is perpendicular, meaning that it makes a right angle down here. So this right here will be our height. Let me highlight that for us. So this right here is our height. So let's put some labels on this shape here. So this is base 1, base 2, and then this guy right here is our height. So now that we know all the pieces, we can now plug things in and start solving. Now I did draw a second trapezoid over here. This is another type of trapezoid. It's actually called a right trapezoid. I'll give you one guess why it's called a right trapezoid. It's right. There is a right angle right here. You are so smart. Look at you getting that. All right. There's a right angle right here. So this is still a type of trapezoid, except for it just has that right angle there. When it comes to this type of trapezoid, same thing. You have a base on top. You have a base on bottom here. But this time, instead of having your height in the middle of this shape, all right, you can actually see the height as that side right here, okay? It is connecting the highest point of the shape to the lowest point of the shape. So that is the height. So right trapezoids are a little easier because the height is actually one of the sides of the shape. So just wanted to go through labeling this guy as well because sometimes you run into a right trapezoid and they're kind of weird looking, so wanted you to be able to handle that. Alright, now that we know all the different pieces, let's go ahead and start solving this. Let's start using our formula. So I have a couple of examples here. Okay, the first one is pretty straightforward. They gave us all of our bases, so it's really a good habit to label all of the numbers that they gave you. So for example, I know that this is going to be base 1, this one is going to be base 2. Now think about it. Does it really matter which one's base 1 or which one's base 2? Okay, you're adding them together. Can't we add in any order? I mean, 1 plus 3 is 4. 3 plus 1 is 4. So at the end of the day, don't get so stressed out about which one is the right base. I always pick base 1 as the top and base 2 as the bottom, but you can do it differently because remember, we can add in any order. So you can do this guy as base 1, the bottom guy as base 1 if you want to. It doesn't really matter because commutative property says we can add in any order. All right, this 2 though is definitely the height. Okay, he's not anything else other than the height. And now that we have all of our pieces labeled, let's go ahead and use our formula. I like to write our formula out so that way it's really easy to remember everything that I want to plug in. So 1/2 times height times base 1 plus base 2. Okay, again, I can multiply in any order, so it really, again, multiplying, I can write this any way that I really want to. Let's go ahead and plug these numbers in. I have 1/2 times the height, which we know is 2, times base 1, which is a 1, those are in parentheses, plus base 2, which is a 3. Okay, once I get those plugged in, order of operations tells me I have to solve my parentheses first, so area equals 1/2 times 2 times 1 plus 3, which is 4. Alright, now it kind of looks like the area of a triangle, sort of. So we kind of have an idea of how to do this. Again, you can multiply in any order. I personally like to multiply these two numbers together first and then multiply times by my 1/2. So I have 1/2 times 2 times 4. 2 times 4 is 8. Alright, now remember we talked about this, I think it was about triangles, that multiplying by a half is the same as dividing by 2. So at the end of the day, when I multiply these together, I end up with 8 over 2. Well, remember that fraction bar right there means that I can divide. And so I end up with 8 divided by 2, which is 4. Okay, isn't 8 divided by 2 4? Yes, it is. So multiplying by a half is the same as dividing by 2. So our final answer is 4, and I got to make sure I put some units on this. So our units were inches, and we just multiplied inches times inches, so that means that it's going to be inches squared. So our final answer here is 4 inches to the second power. Now the other type of problem that you'll see here is they like to give you the area and they leave out the height or another piece of information that you need. So let's take a look at this one. All right, they gave us the area. That's what that is in the middle there. They gave us base 1 and they gave us base 2. Do we have a height here? Our height would be this guy right here, but there's no number there. So we're missing our height. When we're missing a number that we don't know what it is, what do we put? Well, I'm going to put a letter. I'm actually going to put H. Okay? So when we have a number that we don't know, we always put a variable. We put a letter, and so I'm putting H there for that. So let's go ahead and write our formula out so we remember what are we doing. Whoops, sorry, my pen just like totally spazzed out there. My bad. All right. When you write this formula, you don't normally write those multiplication signs there, those dots, but I'm putting them there just to make sure you understand we are multiplying those things together. Now, they did give me my area, so my area A goes right here for 35. I have 1/2. I don't know my H, so the H remains, but I do know my two bases. Base 1 is 4 plus base 2, which is 6. Okay. Order of operations tells me I have to add these two guys together first, so 35 equals 1/2 times H times 4 plus 6, which is 10. Now remember, I can multiply these guys right here. I can multiply them in any order that I want. So instead of trying to multiply 1/2 times h or h times 10, I am just going to go ahead and I am going to multiply my 1/2 times my 10. Now remember, multiplying by a half is the same as dividing by 2. So when I end up doing that, I end up getting 10 divided by 2, or which is 5. So I end up with 5 times h, which we all know is just 5 h's, or 5h. Now, remember when we solved equations, the way to get rid of this 5 that is stuck to the h with multiplication glue, the way we undo multiplication is with division. So I'm going to be dividing this side by 5. And if I do it to one side, I got to keep the other side the same. I got to keep them balanced, okay? We don't want any unbalanced hangers here. So I want to divide by 5 on this side. 5 divided by 5, as we know, is 1, which leaves us that h alone like we wanted. We wanted to know what h equals. And then 35 divided by 5 is 7. All right, the units that we are using here are centimeters. That should be a centimeter. Sorry, my error. So this is going to be, our height is going to be just like our bases here. It's going to be 7 centimeters. Now it is not 7 centimeters squared, because it is not, we didn't find the area. We found a side length. We found the height. And the side lengths here are being measured in centimeters. We are not multiplying a centimeter times a centimeter. All right, so we have our final answer here. I hope that these examples have helped you. Area trapezoids can be a little tricky because you got that adding and that multiplying in there together, but please watch this video over and over again until you got it, and I will talk to y'all later. All right, have a great day.